Hello everyone, I am Ankita Koley. I am a PhD student working with Dr. Chandramani Singh at the Department of Electronic Systems Engineering. Today I am going to talk about our work on fresh caching and delivery of dynamic contents using Restless multi-arm bandits. We consider edge caching network where a base station is associated with the edge cache which is further connected to the cloud server through internet, and the base station has end user population. Now these users are using dynamic applications, for example Facebook, YouTube, Instagram, etc. Now the data of these dynamic applications are getting updated at the cloud server. For example, YouTube's recommendation page or Facebook newsfeed. Now the users are interested in the most recent content or the data, and the edge cache has a limited capacity. And now to serve the most recent data, it has to fetch the content from the cloud server, and to do that it has to, so the fetching of the recent version will incur a high latency. Now here we are interested in caching the dynamic contents to ensure the freshness of the served data to the users, and also to ensure low latency for um, fetching the content from the cloud server. In a nutshell, we are trying to trade off between the user's quality of experience and the latency or the procuring cost to fetch the data from the server, subject to the cache capacity constraints. Now let us consider a particular scenario where we have a single cache and a population of users. Now let us consider a request has come to the local cache which has cached M contents. Now it has found a local copy in its cache. It can serve the stale version, or it can fetch it from the server, and that will incur high latency and content acquiring cost. And after fetching it, it will replace the local copy with the fresh version. There is another scenario where the requested content is not in the cache. In that case, it can fetch it from the server and serve it, incurring a high latency and content acquiring cost. But after serving, it has to decide whether it has to replace the content with the existing one or to discard after serving it. So for that, you have to decide which contents to keep in the cache, where the cache size is given M. Now we consider a hotel index based policy. So the policy is like, suppose a content is requested, first you look if it is in the cache. If it is in the cache, then you look for that, for how long the content has been there. If it exceeds some threshold, you fetch and serve. Otherwise, you serve the stale version. Suppose the content is not in the cache, and then you fetch the requested content, and then you compute the Whittle indices of the all contents, and whichever has the minimum index you evict it. Now how do we compute the Whittle index? We solve the single content problem with holding cost, and then we compute the Whittle indices from that holding cost. And we show that this Whittle index based policy performs almost close to the optimal policy. Now this problem can be extended in more few dimensions. For example, when a content request arrives, instead of instantly serving them, we make them wait. Okay, and depending upon the queue length, we decide whether to fetch it from the server or not. Another extension of this problem is that you consider the link between the base station or the local cache and the central server is wireless. In that case, you have to considered the scenarios whether when you fetch when you try to fetch a survey content, there can be failure in fetching uh, the content, and there will be missing cost or associate missing cost or content rejection cost associated with this content. Thank you.